Hey guys, welcome back to my channel. If you're here for the first time and you enjoy educational content, then please hit that subscribe button. In this video, I'm going to be covering circular measures. So we're going to be looking at the concept of radians. What is radians? We're going to be looking at sectors of circles, and we are also going to be looking at segments. So if you're interested in this, then please stay tuned until the end. Let's get right to the video. First, let's start with some circular measures that you would probably be familiar with. And the first one is the circumference. So the circumference is basically the length of the outline of the circle. This one here would be circumference. And then there's another one that you would be familiar with, and that is the radius. The radius is the length from the center of the circle to the circumference. So it would be this here. Let's label it as R. R for radius. Then we have some new things to learn today. And the first one is the sector. So what is a sector? A sector, imagine the whole circle as a piece of pie. Then the sector would just be one slice of pie. So a slice of the circle is known as the sector. So let's slice up this circle. This would also be the radius. And now we have two sectors. So both are sectors. We have this sector here, the smaller slice, sector. We also have the larger slice. So this is, the rest of it is also known as a sector. So now how do we differentiate between the larger sector and the smaller sector? So we name them major and minor. The larger sector is known as the major sector, the larger piece, and then the smaller slice is known as the minor sector. So we have minor sector as well as major sector. Now, another measure is the arc. What is the arc? The arc is simply a part of the circumference, just one part of the circumference. So again, we have two arcs here. If we look at the part that is covering the minor sector, now, similar to sector, we also name the small one minor. So this is the minor arc. Minor arc. And then we have, of course, the larger one. So the larger arc here, this one, this whole thing is the larger arc, and we call it the major arc. So far we have circumference, we have radius, we have sector, and we have arc. What are segments then? Let's isolate one sector like this. So we have the radius, both sides. Now if we drew a line across like this from one side to the other, if we drew a straight line, this is called a chord. And the segment is actually part of a sector. The segment is simply this area here. This is known as the segment. Now that we know all the different parts of the circle, let's get into the concept of radians. What is radians? Radians is just a unit for angles. So instead of degrees, we also have radians. Now how is one radian defined? One radian, now let's mark the angle first. So we are looking at the angle subtended at the center of a sector like this. Now this angle is known as 1 radian if the length of the arc, so we are looking at the minor arc, when the length of arc is the same value as the radius, then the angle is 1 radian. Now don't get confused, let me just draw this out for you. So let's draw another sector here. So say this was 1 radians and the value of the radius is r. So we have the arc here. The arc is normally marked as S. So we have S. At the point where S is equals to r, this is where the angle subtended at the center is known as 1 radian. Let's see how radians is useful. Now let's say the angle is 1 radian. So let's compare the angle as well as the arc length. If the angle is in radians and the value is 1 radian, by definition we know that the arc length is 1 radius. So 1 radian is 1 radius. If the angle is 2 radians, for example, then we also know that the arc length will be 2 radians. So we can see here that the value of the arc, the length of the arc, is just a multiple of the radius, and that multiple is simply the angle in radians. So for example, if I had 2.5 radians, then the arc length would be 2.5 radians. And this is where we get the formula for arc length, and that is S is equals to R theta. So we look at 2.5 here is the value of the angles in radians. So as the arc length is equals to the radius multiplied by the angle in radians. So this is one thing that we need to remember. This angle must be in radians for this logic to work. If it is in degrees, it doesn't work. So if we are given a value in degrees, how do we get radians? Now let's look how to convert this. The formula for circumference of a circle, circumference is equals to 2 pi r. So we know in one full circle there are 2 pi number of radius. The number of radius in one full circle is 2 pi, which means one full circle, the angle of one full circle will be 2 pi radians as well. So we already know that in degrees it is 360 degrees. This means that 360 degrees is equals to 2 pi radians. And now we know the relationship, we can figure out our conversion. Let's start with degrees. So 360 degrees is equals to 2 pi radians. If we divide both sides by 360, we get 1 is equals to 2 pi over 360. Of course, we go on to simplify this. So 1 and 180, we will get 1 degree is equals to pi over 180 radians. 1 degree is pi over 180 radians. That would mean that 2 degrees is 2 times pi over 180 radians, and that we can apply universally, saying that x degrees would be equals to x multiplied by pi over 180 radians. So this is where we get our conversion from degrees to radians. I will show you a shortcut later. So now let's look at from radians to degrees instead. So let's start with radians. 2 pi radians will be equals to 360 degrees. Now if we divided both sides by 2 pi, then you will get 1 is equals to 360 divided by 2 pi. Now you can notice the similarity here. This is just a reciprocal. So what we do is we simplify it, we get 180 and 1. 1 radian is equals to 180 over pi degrees. Again, we apply the extension of this logic. If there were x radians will be equals to x times 180 over pi degrees. So notice here that this and this are reciprocals of one another. It's either pi over 180 or times 180 over pi. So this is where the shortcut comes in. Now let's say we start with degrees. Let's start with degree, and we wanted to convert to radian. So we are going from degrees to radian. So when we are going to radian, pi is the numerator. So we multiply by pi over 180. It's all about the destination. So if you are going from radian to degrees, from radian back to degrees, then it would be times, this time the number will be the numerator. So 180 over pi. So the conversion is as simple as that. If you start with degrees and you wanted to go to radian, then you would multiply by pi over 180. And if you wanted to go from radians back to degrees, then it would be multiplied by 180 divided by pi. Now let's look at an example. Let's say we had a sector with 2 radians as the angle and 5 centimeters as the radius. So now when we apply the formula, S is equals to r theta. So this will be S, the length of arc. So when we want to find the length of arc, all we have to do is S is equals to r theta. And when we apply the formula, r is 2, theta is 5, and so we would get 10 centimeters. Now this is easy because the angle is already in radian. What if the angle was given in degrees? So let's try another one. Let's say we have another sector and the angle is 30 degrees and the radius is 4 centimeters. Now what would be the length of arc? So the length of arc, again we use S is equals to r theta. Then we do 4 for the radius and 30. Now this time, since the angle is in degrees, we need to convert to radian. So we use the same method to convert. Just look back at the formula here. We are starting at degrees and we are going to radian. So we multiply by pi over 180. So that's all we have to do here. So 30 times pi over 180. So what we get here is 2 over 3 pi centimeters. So this is the length of arc. Now remember that we also have a major arc, and the major arc would look like this if we completed the circle. So let's call this S2. Now what about the length of the major arc? We apply the same formula here, but this time we go with S2. So S2 is still equals to r theta, but now the value of theta will be different. The value of r is still 4, so this is 4. Now what about the value of theta? So the value of the major arc here, this is 360 minus 30, which is 330 degrees. Therefore, this will be 330. Now don't forget, we have to use the angle in radians. So we use the same method of conversion, times pi over 180. And when you key this into your calculator, you will get 22 over 3 pi centimeters. What about the area of the arc? The ratio of area of sector, the ratio of the area of the sector to the area of a circle is the same as the ratio of the angle subtended at the center. So let's call the angle subtended for the sector just theta, and then we have theta of circle. Now let's fill in the values. Area of sector over, now the formula for area of circle is pi r square, so let's use pi r square. Now the angle, this is a variable, but the angle of a circle is 2 pi radians. So take note that we are using radians here, which means the value of theta must also be in radians. Now the reason that we use in radians, let's make area the subject. So area of sector is equals to 2 theta pi r square over 2 pi. Multiply both sides by pi r square. So we will get, eliminate pi. Now all that's left here is, we rearrange this to be area of sector is equals to half r square theta. This is the formula for area of sector. Remember, this value of theta must be in radians. It cannot be in degrees for us to apply this formula. Now let's look at the example. Let's take the same sector as just now. So let's start with radians. 2 radians and 5 centimeters. So we just apply the area formula. Area of sector equals to 1 over 2. Now the radius is 5. So 5 square and theta. Theta here is 2 radians. 2 radians, so times 2. what we will get is 25 centimeters squared. So this is the area of a sector. Now what happens if we are given the area in degrees? So again, all we have to do is convert to radians. Let's say it is 30 degrees and 6 centimeters. Now let's try this. Area of sector will be equals to 1 over 2 6 square theta. Now again we have to convert it to radians. So 30 multiplied by pi over 180. This is how we get the answer in radians. Then just simplify 1 over 6, and so we will get 6 divided by 2, which is 3 pi centimeters square. So this is how to calculate area of sector using half r square theta. Now we are done with sectors. What about segments? Now let's draw our segment again. So we have a segment. We draw a sector. Segment is simply part of a sector, so we draw a segment first. So let's label again. So this is the angle theta, this is the radius, and then don't forget about the chord. So this is the chord. This straight line here that runs across is called the chord, and then this here is the segment. This is the segment. There are two measures that we can take from a segment, and one is the perimeter, the other is the area. So first let's look at the perimeter. Now in order to find the perimeter, let me mark the perimeter first. So the perimeter of a segment is this arc of sector plus the length of chord. That's all, that's our perimeter. So we already know how to find the arc of a sector. The problem is the length of chord. So this can be easily found if we draw two triangles. So if you notice, this is already a triangle. This is a triangle, and both sides are the length of the radius, which means this is an isosceles triangle. Now, when we divide this isosceles triangle exactly into two at the center, then this is 90 degrees and this is 90 degrees. And now each side, the angle is theta over 2, theta over 2. Okay, so we have to use a little bit of trigonometry here. It's not very difficult. So here we have, let's name this half of the chord x. So this would be x as well because they are the same length. Now let's use some trigonometry. So this angle, the opposite is x, and we have the hypotenuse. When you have opposite and hypotenuse, then we use sine. So sine of the angle, sine of theta over 2 is equals to opposite over hypotenuse. So opposite is x, x over the hypotenuse is r. So we have opposite x over r. Now when we rearrange x to be the subject, because remember we are trying to find the length of the chord, so x will be equals to r sine theta over 2. Alright, just one note here. This value of theta over 2, whenever we are using trigonometric ratios, whenever we are using trigonometric functions, you have to use the angle according to the calculator. So the normal mode of the calculator is in degrees, unless you changed it. Normally this is the case. You have to check with your own calculator. But normally if you don't do anything, it is in degrees, which means the value that you use here must be in degrees. Unless you have set your calculator to radian mode, then you have to use radian. So it depends on the setting of the calculator. However, usually it is in degrees. Right? So the length of chord, length of the whole chord will be equals to 2x. The whole chord is 2x, which is equals to 2 times x is r sine theta over 2. So 2 r sine theta over 2. Now this is the length of chord. Now again remember, this has to be in degrees, not in radians, unless your calculator is set to radians. Alright, so now how to find the perimeter of the segment? All we have to do is add the length of chord to the length of the arc. So we have perimeter of segment will equals to length of arc, S is equals to r theta, remember that this is S. So we have r theta plus, then we have the length of the chord, which is 2r sine theta over 2. So when we are using the perimeter formula, there is one thing you have to be very careful about, because in this formula, one of the angles, remember when we use S is equals to r theta, the angle must be in radians. So for r theta, it must be in radians. However, for theta over 2, it must be in degrees, unless your calculator is set to radian. So this is the formula for perimeter of the segment. Now, let's see an example. Let's say we had a sector that is 30 degrees and 3 centimeters. Alright, so then let's draw a segment. Draw a line here. So this is our segment. So how to find the perimeter of this segment? All we have to do is apply the formula. So perimeter is equals to r theta plus 2r sine theta over 2. Now we just have to substitute the values inside. So this is where we have to be careful. R is 3. However, theta here must be in radians. This must be in radians. So we have to convert 30 degrees to radians. How do we do that? 30 times pi over 180. So this is r theta, and then plus, here we have 2r sine theta over 2. So again, just put in the values. 2, r is still 3 sine theta over 2. So this time we use degrees. This angle must be in degrees. So all we have to do is 30 over 2 degrees. So when we punch this into the calculator, you will get a value of 3.124 centimeters. So this is the perimeter of the segment. How about the area of the segment? So let's look at area of segment. Let's say we have another sector. Okay, this is the segment. Alright, so let's break this sector down. First, we have the segment, and then we have our triangle. And the whole thing, of course, is a sector. Now, there's no formula to directly find the area of the segment, but we can find the area of the segment by subtracting the area of the triangle, this triangle here, from the area of the sector, which is the whole thing. Whole thing is the sector. So now we just have to apply all the formulas that we already know, that we've learned so far. So this is the radius and this is the angle theta. So let's do this. Area of segment is equals to the area of the sector minus the area of the triangle. So let's apply the formulas. Area of sector is 1 over 2 r square theta, remembering that theta is in radians here, minus, now here you have to remember the formula for a triangle. If you don't know this formula, you can check out my lesson on solution of triangle. I will include it in the description. So it's actually, when we look at a triangle, when we look at this triangle, just use a different color. So this is r, and this is theta. So if you're familiar with the formula, half AB sine C, 1 over 2 AB sine C. That's exactly what we are using here. So the angle would always be C, sine of C. So this is C, which means this is A and this is B. So that will translate to the area of the triangle is half A and B are R. So R square sine theta. C is theta. So sine C will be sine of theta. If you look at this carefully, you can see that we can factorize half r square, 1 over 2 r square, because they are present in both terms. So when we factorize it, it will become 1 over 2 r square bracket theta minus sine theta. Now we have to be very careful here, because again this theta is in radians, whereas this theta is in degrees. So when we are doing our calculation, so let's try an example. Let's say we have a sector and then the angle is 30 degrees and then the length is 6 centimeters. Alright, so now we want to find the area of this segment. We just have to apply the formula. Area equals to 1 over 2 r square, so we use 6 square. Now theta, again theta must be in radian, so we have to convert 30 degrees. Use the same method we've been using throughout the video, multiplied by pi over 180. So this is theta and then minus sine of theta. Now this theta has to be in degrees. Remember, whenever we are using trigonometric ratios, you must use degrees unless your calculator is set to radian mode. 30. Now we can go and key in your calculator and you will get an area of 0.426 centimeters square exactly. So this is how to apply the area formula. So throughout this whole topic, you can see that whenever we have trigonometric ratios, you have to be careful to use the angle in degrees unless your calculator is set to radians, which normally is not. However, in all the other formulas with S is equals to r theta, and whenever we are using half r square theta for the area of the sector, and in other places like the area of the segment where you use those formulas, you incorporate those formulas inside. So if you notice here, we look at all of our formulas, whenever there is no trigonometric ratio, whenever there is no sine, then the angles are in radians, like this. There's no sine of theta, angles are in radians. No sine of theta, angle must be in radian. So if you have any questions, please don't hesitate to ask me in the comment section below. And if you've enjoyed this video, please help me by hitting that like button. It really does help. It's very important that YouTube recognizes that this is a good video so that it gets shown to more people and more people can learn. So if you like daily short lessons and you want to do some revision, you can follow me on Instagram as well as TikTok. I do daily revisions there. Thank you for watching all the way to the end. I'll see you in the next video.